Bismillahirrahmanirrahim. Today we are going to do the exercise of chapter 7, deformation of solids. Today we will do assignment 7.1 and numerical number 1. In assignment 7.1, the statement is the suspension cable to use cable cars at Murree has an unsupported span of 3.25 kilometers. Calculate the amount of stretch in the steel cable of diameter 6 cm for its maximum load. The question on weight is given by the engineers to not more than 4 into 10 raised power 6 Newton. So the length of span is given to us, that is 3.25 kilometers. We have to determine the amount of stretch. Diameter is 6 centimeter and the maximum weight that the span can lift is 4 into 10 raised power 6 Newton. So in the figure you can see the span. The length of this span is given to us. It is 3.25 kilometers. The data is given in kilometers. We have to convert it in meter, and in meter we will get 3.25 into 10 raised power 3. Diameter of the cable is 6 centimeter. Again we have to convert this centimeter into meters. So in place of centi we will write 10 raised power minus 2. And the maximum weight which it can lift is 4 into 10 raised power 6 newtons. To find, we have to find the amount of stretch in steel cable, that is del L. And formula that we will use for this purpose is Young's modulus, that is Young's modulus is equals to stress by strain. We will substitute the value of stress and strain in the formula. We know that stress is force per unit area and strain is del L divided by L. We will rearrange this formula. F by A can be written as it is, and this term is rearranged in the way that it is in the most denominator. It will be taken in the numerator and this will be in the denominator. Del L will be in denominator and L will be get multiplied with force. Okay, rearranging this formula, as we have to determine the value of del L, so we will rearrange it according to the value of del L. We will take del L on left hand side and Ys on right hand side. Ys is the Young's modulus for steel. It may be given to you in the question, and mostly definitely it is given to you in the question. Otherwise you can memorize it, that value of Ys is 20 into 10 raised power 10 pascals. Also, the area is not given to us. We have given the diameter of the cable, but we know that area is equals to pi r square and r is equals to d by 2. So substituting the value of area over here, we will get all the values, all the terms in the formula which are known to us. So we can substitute the values to get the result. Here we are putting the value of A, that is pi d by 2 whole square, and now we know all the values of all the terms given to us, that is force is 4 into 10 raised power 6, diameter is 6 into 10 raised power minus 2, the value of pi is 3.14, value of L is 3.25 into 10 raised power 3, and value of Young modulus for steel is 20 into 10 raised power 10. Solving all these values, multiplying and dividing, we will get the result of change in length as 23 meters. Now numerical number 1. The statement of numerical number 1 is calculate the mass of picture frame hanging with the from a steel nail which is sufficient to produce a force providing shear strain as shown in the figure. Given that the nail bends only 1.80 micrometer, also discuss the results. Okay, we are given a mass frame and which is hanging with the nail. There it is represented by the arrow, blue arrow, and the weight of this picture frame is unknown. Basically we have to find the value of the mass of this picture frame which is making this nail to be bent at a distance of 1.80 micrometer. This distance is very small that we cannot observe it by naked eye, but it is given to us that the bending in steel nail is 1.80 micrometer. The length, original length, or you can say the value of Y for the steel nail is 5 millimeter, and the diameter is given to us, it is 1.50 micrometer. We have to determine the mass of the picture frame. So according to the given data, bending in the nail is 1.80 micrometer. The unit is the micrometer. So firstly we will convert it into meters. We will get 1.80 into 10 raised power minus 6 meter. Diameter of nail is 1.50 millimeter, which can be again converted into meters by substituting the value of milli, that is 10 raised power minus 3. Value of y is 5 millimeter, that is 5 into 10 raised power minus 3 meters. And we have to find mass of picture frame, that is m. Formula that we can use for this purpose is by Shear's modulus. Shear modulus is shear stress divided by shear strain. We know that the shear stress is equals to force per unit area and shear strain is del x divided by y. We have given the value of del x as well as of y. So we can rearrange the formula. Y will get multiplied and del x will get divided. We know that force is equals to mg. Force is basically equals to weight, which is equals to mg, and we have to determine the value of m. Moreover, the shear modulus for steel is 8 into 10 raised power 10 Pascal. You can memorize it, otherwise it will be given in the examination. In fact, in this question the value of Young modulus is given to us, but as it is clearly mentioned in the question that force is producing a shear strain, that means we don't have to use the Young's modulus formula. Instead we have to use Shear's modulus, that is 8 into 10 raised power 10 Pascal. And also we know that area, as diameter is given to us, we know that area is equals to pi r square. So in place of r we can write d by 2 because radius is half of diameter. Putting all these values in the formula, we will get the formula for shear modulus as mg divided by a into y divided by del x. Similarly, we can we can rearrange the formula as we have to determine the value of mass. So we will keep mass on right hand side and take all other values on the left hand side. Substituting all the values, we will get the result for mass. Here in place of a I have written pi, which is 3.14, and d by 2 whole square. Diameter is given to us 1.50 into 10 raised power minus 3 divided by 2. Value of g is known to us, that is 9.8, and del x is 1.80 into 10 raised power minus 6 and y is 5 into 10 raised power minus 3. Solving all these values, we will get the result for mass of frame as 5.19, which can be rounded off as 5.2 kgs.